हेलो एवरीवन एंड वेलकम टू दिस चैनल। तो आज हम लोग स्टार्ट करने वाले हैं इलेक्ट्रिकल साइंस का यूनिट 3। तो उससे पहले मैं कुछ चीज़ें आपसे क्लियर करना चाहता हूँ। तो जो भी हमारा यूनिट 3 एंड यूनिट 4 है ऑफ इलेक्ट्रिकल साइंस, उसमें मेजॉरिटी पार्ट हमारा थ्योरी का है। बहुत ही कम चीज़ें हैं जिसमें मुझे कुछ एक्सप्लेन करने की ज़रूरत है। तो आगे आने वाली वीडियोज़ काफ़ी ज़्यादा मोनोटोनस हो सकती है, बट आई कैन गारंटी यू दिस थिंग कि जो भी यहाँ पे थ्योरी करवा रहा हूँ मैं, अगर आप सिर्फ उसको प्रिपेयर अच्छे से कर लो, so you can easily tackle your exams. तो स्टार्ट करते हैं हमारा पहला टॉपिक which is the DC generator. So DC generator is the type of machine that is used to convert mechanical energy into electrical energy. Now there are mainly two types of DC machines. The first one is DC motor and the second one is DC generator. And यहाँ पे हम लोग बात करेंगे हमारे DC generator की। तो सबसे पहले हम बात करें about the construction. So the stationary part of the DC generator is called as the stator. This outer portion is known as the frame or yoke that plays an important role in the DC generator. It provides mechanical strength and it protects from any mechanical damage. Now the frame provides the support to the pole core and it provides low reluctance path for the magnetic flux. And here the stator core of DC machine where poles remain present, the structure of the pole remain like this. It consists of the pole core and the pole shoe. Now the stator core is made up of laminated silicon sheet and the silicon sheet has high permeability that supports the magnetic flux by providing easy path. And the lamination is the arrangement of various thin sheets to reduce the eddy current loss. Now the surface of pole core remains curved. Usually the pole core and the pole shoes are made up of cast steel and the pole core has different features. Pole core provides support to the field coil or the exciting coil. It spreads the magnetic flux towards the rotor periphery and the pole core increases the cross-section area of the magnetic path. Now the field winding remain placed around the pole core, that is also known as the exciting coil, and the main purpose of the field winding is to produce the magnetic flux. Now the field winding is made up of enameled copper wire. Enamel coating provides for insulation and field coils connected in series and it develops opposite poles between adjacent poles. Now the rotating part of the DC generator is called as the armature. The armature core has cylindrical shape and also we provide lamination to reduce any kind of eddy current loss. Now the slots are present at the outer portion of the armature where we place armature winding, and there are two main purposes of the armature core. The first one is it houses the armature conductor in the slots, and the second one is it provides an easy path for the magnetic flux. Now the armature is the rotating part of the DC generator, so there will be more chances of hysteresis loss, so it is made up of laminated silicon steel. Now the diameter of the lamination stamping of the armature core remains about 0.3 to 0.5 mm thick and each lamination is insulated to each other by coating of varnish. And the insulated armature coil is placed in the slots of the armature. Now the energy conversion takes place where armature winding placed. In case of DC generator, mechanical power is converted into electrical power. Now there are two types of armature winding. One is lap winding and the second one is wave winding. Now in lap winding conductor, the arrangement is like the number of parallel paths is equal to the number of poles. Next comes the commutator. So it is the most important part of the DC generator. It rotates with the armature and it is made up of hard drawn copper bars. Each commutator segment connected to the end of the armature coil. It connects the rotating armature with the external circuit through brushes and it converts the induced AC voltage into DC voltage. So this was the particular structure of a DC generator. अब हम लोग बात करते हैं about the working of DC generator. So the copper winding placed at the pole of the stator where we give DC to produce our electric field flux. We use electromagnet or permanent magnet to produce our field flux. Since the DC generator converts the mechanical input into electrical energy, so we use external prime mover to provide mechanical energy. Now as the prime mover, we can use anything that is IC engine, steam engine, water wheel turbine, etc. When armature rotates, then the armature conductor cuts the constant magnetic field, so it leads to electromagnetic induction. अब हमें पता है that in case of electromagnetic induction, whenever the varying conductor cuts the stationary magnetic field, then EMF induces in the varying conductor. And whenever changing magnetic field cuts the stationary or constant conductor, then EMF induces in the conductor in that condition also. So when the EMF induces in the armature conductor, then the AC current circulates. Initially, the AC current induces which direction to determine by the Fleming right-hand rule. And the commutator converts the induced AC current into DC current. And the connected brushes collect the DC current and they supply it to the load. Thus, the DC generator converts the mechanical energy into DC electrical energy. Now, when we give external excitation in DC generator, then that type of DC generator is known as separately excited DC generator. When we give excitation from output of the DC generator, then that type of machine is known as self-excited DC generator. To produce field flux in DC generator, we can use electromagnet or permanent magnet. Usually, electromagnet is used in large size DC generator. अब हम लोग बात करते हैं about introduction to DC motor. So DC motor is the electrical machine that converts DC electrical energy into mechanical energy. Now that electric motor which runs by using DC supply is known as DC motor. अब बात करें हम लोग इसके कंस्ट्रक्शन की, तो इसका कंस्ट्रक्शन बहुत ही ज्यादा सिमिलर है to DC generator. So stator is the stationary part of the DC motor. At outer portion of the motor is known as the frame or yoke that is made up of cast steel. It supports the stator core and protects the internal assembly of the motor. And it provides easy path for magnetic flux produced by the field winding. Poles are present at the inner portion of the stator where field winding remain placed. This portion of the pole is known as the pole shoe that supports the field coil. It reduces the reluctance of the magnetic path by increasing the area. The pole core is made up of laminated silicon steel. The arrangement of various thin sheets that combine together is known as a lamination. To reduce the eddy current loss, we provide lamination in the electrical machine core. Now the field coils are connected in series like alternate poles develop on the poles. The rotating part of the DC motor is known as the armature, and the armature core is made up of laminated soft steel where the lamination sheets are insulated. The armature core mounted on the shaft and the slots are presented on the outer portion. The insulated armature winding remains placed. To insulate the armature conductor, the coating of the varnish is used. Now there are two types of winding which can be used, either the wave winding or the lap winding. The commutator is the most important part of the armature that behaves like a rectifier. The carbon brushes are attached with the commutator through which the DC supply is given, and it is the copper segment, and each segment is connected to the end of the coil. Now the construction of the DC motor is just like the DC generator, but the working is slightly different. So the DC generator converts the mechanical energy to electrical energy, but the DC motor converts the electrical energy to mechanical energy. So let us talk about the working in case of DC motor. So we give DC supply to the field winding. As a result, the constant flux is produced, as well as we energize the armature winding through brushes and commutator. Whenever current carrying conductor placed in the magnetic field, the conductor experiences electromagnetic force in the tangential direction from the Lorentz law. Here also, the current carrying armature conductor that is placed in the magnetic field, so according to the Lorentz law armature, conductors will experience a force on them. As a result, the armature starts to rotate. So direction of rotation is determined by the Fleming left-hand rule, and the commutator and brushes play a very important role. It reverses the current at the half rotation, so that the armature will rotate in the same direction. Now let us talk about another important term, which is the back EMF. So during operation of the DC motor, when the armature cuts the stationary magnetic field, then EMF is induced due to the generator action. Back EMF opposes the supply voltage. Now back EMF का एक formula भी होता है, which is EB is equal to NP phi Z divided by 60A, where EB is the back EMF, A is the number of parallel path, P is the number of poles, N is the speed of the armature, Z is the total number of conductor in the armature, and phi is the magnetic flux. अब बात करें हम लोग about classification of DC motor, तो ये सारी types के हमारे पास DC motor होती है. Now coming to the advantages, so DC motor has a smaller size. It operates on DC supply, so we can use electronic device. DC motors are suitable for traction purpose. DC series motor has high starting torque. DC motor has wide range speed control, and it has a quick starting, reversing and fast acceleration. Now coming to the disadvantages, so the initial cost of DC motor is higher, the maintenance cost is high due to the commutator and brushes, and the sparks are created at the brushes, so it is not used at explosive application. So that was all for this video, and I will see you in the next one.